All right, for today's deep dive, we're getting into something that tackles a really frustrating problem in commercial AV installs.
Oh, yeah. The classic headache of running high-res digital video over any kind of distance.
Exactly. We're going to dissect the engineering behind a very specific product, the PureLink EZD-020 Easy DVI over detachable fiber cable.
And this is important because we're looking at a solution that's really built for simplicity and, I think, reliability. It's
Mhm.
all about overcoming those physical barriers that make old school DVI a bit of a nightmare.
And just to give you some context, the 20-meter version we're looking at today runs about
That
$349.99.
sounds like a lot, but you have to look at the features you're getting for that price.
Right. It's fully HDCP compliant, so it handles all the encrypted content just fine. And crucially for commercial spaces, it's plenum rated.
And that plenum rating is a big deal. It's really non-negotiable in a lot of buildings. It means the cables jacket has the right fire safety rating to be run through air handling spaces.
A huge headache saved during inspections for sure.
Yeah.
So, okay, let's talk performance. What kind of signal quality are we actually maintaining over that fiber?
The quality is, well, it's phenomenal. You're getting full WXGA, that's 1920 by 1200 at 60 hertz,
Okay.
and, 1080p and even 36-bit deep color. And the key is this quality holds up over the cable's maximum range, which can be up to 100 meters.
100 liters, so 328 feet.
Yep. And standard copper DVI just can't do that without some serious, bulky, active boosters.
Okay, that immediately brings up the power question for me. If you're pushing an active signal that far, you almost always need an external power brick, a wall wart or something.
Right.
But the source material says this is plug and play, no external power.
Yeah.
How does that even work?
And that's the core technical nugget, isn't it? The real innovation is that they've managed to build tiny, super efficient transceivers inside the DVI connector heads themselves.
So they're self-powered.
In a way, yeah. They draw the tiny amount of power they need directly from the source device, like your computer, and the display on the other end.
So it completely eliminates the need for that separate power injector.
Which, as you know, is usually the first point of failure in almost any long-run setup.
Absolutely. That alone simplifies deployment and maintenance so much.
Immediately.
Now, let's get to the physical side, the part they call easy in, easy out. I mean, fiber is thin, but DVI connectors are famously chunky and stiff.
This is the aha moment. It's for anyone who's ever tried to wrestle one of those giant DVI heads through a 1-inch conduit. It's just impossible.
Right.
So the design lets you completely detach the main transmitter and receiver connector bodies. You're left with just the ultra-thin fiber cable.
So you pull the thin cable first.
You pull that skinny cable through the conduit, and then you just snap the full-size DVI bodies back on at each end. It's brilliant.
That completely changes the installation game. But okay, here's the challenge then.
Yep.
When you have those protective heads detached, what about the fiber itself? Isn't there a risk of, bending or breaking it?
That's a valid concern. The source materials do stress the construction here. The cable itself is built to be durable, and the sheath over the fiber is designed to withstand a typical pull through a channel.
So it's not just a bare, fragile strand.
No, not at all. And they back it up with a mean time between failures and MTBF of 50,000 hours. This is engineered for high reliability, long-term installs.
That 50,000-hour figure is key. And when you connect that reliability to the fact that it's TAA compliant, so it meets federal procurement standards.
Well, then it becomes very clear this was designed for environments where failure just isn't an option. Government, defense, that kind of thing.
So what does this all mean for you? I mean, this is a product that solves a really tough installation problem while keeping top-tier performance and getting rid of common failure points.
It's the very definition of engineering simplicity into a complex problem.
It proves that you can modernize an older standard like DVI 1.0 just by changing the medium it runs on. So this makes me wonder, and it's something for you to think about, what other legacy standards out there are being quietly revolutionized by fiber optics right now, saving time and money on big projects?